Hello everybody. In this lecture, we are going to study about how can we find the address of a particular memory location inside the one-dimensional and two-dimensional array. First, we will discuss with the one-dimensional array. For that, we have one formula. So let's see this formula. In this formula, you can see if you want to find the address of particular memory location, suppose I, then this formula we will apply and we can find out the answer. In this formula, I is the index of the element for which we want to find the memory address. B is the base address, means this is the first address or first memory location of the array. That's why it is called base address. W is the size of the particular element, or suppose we are using integer type of element, then what is the size of a particular integer? LB stands for lower bound. Sometime in the array it may be possible that the array index will not start from 0. Okay, let's suppose I'm taking one example, and this example, this is your first array element. Okay, in this case, lower bound may start from, let's suppose, -3. So in that case, LB value will be -3. By default, we will consider as a 0 if this is not given in the question. So let's see this example, and then we will apply this formula to find out the address of a particular memory location. So given the base address of the array A 1100 to 1900 as 1020, means this is your value of B, and size of each element is 2 byte in the memory. So we have to find the address of A of 1700. So here we will write all the given information in our question. So B is given as 1020. Then next W is given as a 2 bytes. Then I is the 1700 because we want to find the address of A of 1700. And the lower bound which is given in the array is 1100. So all the information is given to us. Now just we will apply the formula. You can see the formula above, where B is 1020 plus W is 2 multiplied by I minus 1700 minus LB. LB is your 1100. So let's solve this question. This is your final answer. So in this way, we can find out the address of particular memory location in the one-dimensional array. Now we will discuss the formula for two-dimensional array. In the two-dimensional array, we have discussed about the two types of representation. One is row measure order and another one is the column measure order representation. First, we will discuss about the row measure order representation formula. The formula for the row measure order is this. Here, if you want to find the address of I and j, A of I and j, then this formula we are going to use. And inside this, I is the row subset of an element whose address is to be found. Similarly, j is the second index, means column index. B is the same as this was there in the one-dimensional array, that is base address. W is the storage size. LR is the lower limit of the row, means starting index. What is the starting index of the particular array? LC is the lower limit of the column, means if suppose array is starting from -1, -6, then in this case the lower LR value and LC value will be -1 and -6. So this is starting array, starting element we can say. In this case, N is the number of columns given in the matrix, which is here. By this term, we will multiply this value of n, which is number of columns. So let's discuss one example by that we can understand what are these values representing. Given an array of 0 to 10 and 0 to 15 with a base value of 100 and the size of each element is 2 bytes in the memory. Find the address of array of 86 with the help of row measure order representation. So whenever question will come in the exam or any competitive exam, then row measure order will be given, or it is column measure order. Whatever question is there, it is given to you. In this case, we will write all the information which is given to us. So first of all, we'll require B. So B is given as 100. Second thing I will require is W. W is 2 bytes. The value of I. The value of I and value of J is given as 8 and 6. Means we want to find the address of this 8, 6. That's why the value of I and value of J is 8 and 6. Next thing I will require is LR. LR is the lower bound, or we can say it's the lower limit of the row. Lower limit of the row, you can see here it is starting from 0. That's why LR is 0 and LC is also 0. You can see here this value or this index is starting from 0. That's why this is 0. Next I will require is the value of N. N is the number of columns. So in this case, the number of columns we have is this many, means 0 to 15. 0 to 15 means it is total 16 columns are there. Now we will substitute the values in the formula and we will get the answer. Is 8, 8 minus 0 multiply by 16 plus J value. J value is your 6. LC is 0. So this way you can find out the answer. You can have confusion in the size of the or number of column and number of rows. So if the question is given like 10, 15, then your index is starting from 0 and it is going till 9. And the column index will start from 0, it is going till 14. But if this given information is like this 0 to 10 and 0 to 15, means we have total 11 rows and 16 columns. And in this case, we have exactly the 10 number of rows and 15 number of columns. Next, we will discuss about the column measure order formula. The column measure order formula will have one change where the value of n which we are multiplying now this side means in the column term we will multiply the value of n, and the n here represent the number of rows. In the row measure order formula, it was number of columns. So just opposite, in the column measure order, we will have this n value as a number of rows. So I and j is the indexes for which we want to find the answer. The base address is B, W is the size of particular element, and LR and LC is the lower limit of the rows and column respectively. N is the number of rows. So let's check the formula and we will find the answer. You may pause a little bit and you can find out the answer for this question. Okay, so let's write all the information which is given to us, that is B value which is 100, W value which is given as 1 byte, I value, which is we want to find the answer, is 8. J value is for 6. LR value is given as 1 now. You can see here is the lower limit of the row and lower limit of the column, which is given as 1 and 1. And the N value. N value you see number of rows. And number of rows in this case is 1 to 10. And 1 to 10 means it is 10. Now just substitute the value, we get the answer. So in this way, we can find the address of any particular memory location inside the one-dimensional and two-dimensional. Thank you for listening.